Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of representing linear proportional relationships. This is standard 8.5a in the great state of Texas, and we are using item number 31 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got a survey of customers, and all we get is 7 out of 10 customers preferred the restaurant's new spaghetti sauce. So which graph shows the relationship between y, all right, so they're going to give us our x and y coordinates, the number of customers who preferred the new spaghetti sauce, so that's going to be this right here, first number, and then x, total number, 7 out of 10. 10 is going to be our total. And I guess since all of our options here are linear graphs, we're going to assume that this constant rate stays. Like if we asked 20 customers, we would get 14 and so on and so forth. So we're assuming that's representative. So how do we best represent this? Well, they actually give us our x, y coordinates. Now they do that reverse, so that's why it's very important to label them, right? So this y is the number of students, customers who preferred the new spaghetti sauce. That's 7. And then we've got 10 is the total number. So even though they give it to us at 10 out of 7, or 7 out of 10, we have to kind of switch that into a 10,7 if we want to put that on a graph. Now, what is our constant of proportionality? So this is something we learned about in the 7th grade. We're going to look at that right there. So that constant of proportionality is going to be that y over x, and they just give it to us. It's in that fractional form, 7/10. Or if we really wanted to get technical, we could probably represent that as a decimal, 0.7. So 2 questions to ask here that's going to help us decide which of these graphs is the best. First, what happens if x is 0? If x equals 0, question. Because that's going to let us know whether we have direct variation or whether we're going to use the slope-intercept form. So the slope-intercept form, remember, is this. And that constant is just going to be an m rather than a k. But we have a y-intercept here because if x is 0, y is still something. And so these are non-proportional graphs. Or we've got the direct variation, which is y equals kx. If x is 0, y is also 0. It doesn't matter what you multiply by, and these are proportional, and they go through the origin. And so let's just think about this for just a moment. X is the total number of customers, okay? So if the total number of customers that you can ask is 0, how many of those 0 customers will prefer spaghetti sauce? Okay, well that's pretty obvious. If x is 0, y is going to be 0. If you ask 0 customers, then you're going to get 0 of those customers preferring the new spaghetti sauce. But that lets me know that the origin is going to be one of the points on my graph, which means I'm going to cross off C and D. Check this out, because those are not proportional. They don't go through the origin. And so let's just look at, we've got the origin in both A and B, and now let's just plot the other point that they give us here, and that's 10,7. So you notice that we've got kind of different scales here for both of them. So 10,7 looks like it is a point on the line here on A. So that's going to be 7. So I'm going to guess my 10 is like here-ish, and then my 7 is going to be here-ish. And so I'm looking, it looks like that's not going to do it. If it is proportional there, right, 10,7, like I would get 20, 14. Yeah, that's going to be a point for me. So yeah, it looks like my best answer here is going to be A.